Hi guys, in this video I cover the concept of the stack data structure. A stack is essentially a specialized version of a linked list in that we only add items at the front of the list and we only remove items from the front of the list. There are two ways to look at a stack, conceptually and implementation-wise. Conceptually, we envision it as a vertical stack where we push items on top of the stack and we pop items off the top of the stack. Implementation-wise, it's a linked list where we insert new head nodes at the beginning and we remove the head node when we remove an item. Conceptually, we talk about push and pop operations. Push means adding a value to the stack. Pop means removing a value from the stack. The stack is a LIFO data structure, which means last in, first out. So the very last value that was pushed on top of the stack will be the first value that's taken off the stack. Initially, the stack is empty, its size is 0. And as we push items onto the stack size grows. As we pop items off the stack size shrinks. Now there are three main operations, which are push, pop, and the check if it's empty. Push takes a value and pushes it on top of the stack. Pop removes the last value at the top of the stack. Is empty checks if the stack is empty, and peek returns the value on top of the stack without removing it. This is the conceptual idea. Now let's take a closer look at the implementation. So stack implementation is a linked list. We have a head pointer that's initially null, and for every value that is pushed onto the stack, we create a new node and update the head pointer to point to that node. For every value that's popped off the stack, we remove the head node. Now it's important that all other nodes still remain in the list. Now let's go back and go over these four operations and focus on the implementation. So push item will take the item or the value and create a new node, then update the head pointer to point to the new node, and the new node's next pointer will update to the previous head node that was there. So we basically insert a node at the very beginning of the list. The pop operation will remove the head node. So basically we update the head pointer of the list to point to the second node in the list. That removes the value from the list. Is empty simply checks if the head pointer points to null, and peek returns the value of the head node. Now let's take a look. On the right, you can see the conceptual illustration of a stack. And here on the left, you see it in terms of a linked list. So I call the head pointer here stack, and stack points to null. Now, if I call the push operation, implementation-wise, I have to create a new node, take the head pointer called stack here, and point to the new node. On the right, it simply pushes an item onto the stack. So it would be at the very beginning here. So we can see 3 is now onto the stack. On the implementation, we have a linked list with a single node that contains 3. Now we want to push 5. 5 becomes the new head node. So we always insert in the beginning. Conceptually, we push 5 onto the stack. Now take a moment and think through where 6 will go. Where will it go in terms of implementation? Where will it go in terms of stack? So in terms of stack, it's easy. We just push it onto the stack. It will be right here. In terms of implementation, we create a new head node that will be inserted here. And then the node that contains 6 will point to 5. So we can see 6 was added here and pushed onto the stack here. Now, what about a pop operation? So pop operation, conceptually, we want to pop 6 off the stack, so we remove it. Implementation-wise, we remove the node 6. Now if I call pop again, 5 would be removed. Here the node, and here 5 off the stack. So this is really just the concept. When you implement this, you use a list. So what is big O? Time complexity. Push operation It's just inserting a new node. We don't have to iterate the list. We always insert it at the very beginning. So we create a new head node. So it's O1. Pop operation just operates on the head node. It's O1 as well. Peek operation, just taking a look at the very front, returning the value of the head node. It's O1. And to check if it's empty or not, that just checks if the head pointer points to null, which is also O1. So it's very performant. Now to recap, again, a stack is a linked list with two main operations, push and pop. We insert a new head node or we remove the head node. I hope you enjoyed this video. Thank you for watching.